My name is Ed. I am one of the co-founders here at Barnabas Robotics. I'm really excited today to show you guys how a toy builder thinks. If you go into the toy store or Walmart or go shopping on Amazon, you see a bunch of toys there. I want to just kind of peel back that a little bit. Behind all those toys, there is an inventor, someone who has thought up that concept, prototyped it, meaning that like got pieces together to make it work, and then it became a toy. So today, that's what we are going to do. Now, what are we building today? Because it's the month of March currently when I'm making this video, we're going to go with a shamrock, because that's kind of like St. Patrick's Day and that kind of thing, so it goes with the theme of March. And this shamrock is actually going to move or dance, so that's where the robot movement comes out. And I wanted to challenge us today in building a on and off switch that doesn't just work by physically turning it on and off like a light switch. I wanted to add a switch that is controlled by light. Okay, so that's the story. That's the goal today. So let's go ahead and get started. Okay, so here are the parts here, this little bag here, and so let's go ahead and open it up and check out what we have. All right, the first thing is, I always like whenever we're inventing buildings, just kind of like organize your parts. Okay, there's this cup here, we're gonna need that. There's this shamrock here, we're gonna need that. That's part of our dancing shamrock. And then what else? These two googly eyes, we're gonna need that. Okay, now all this other stuff right here, okay, we're gonna just put it to the side for now. All right, so first step is really just to take the shamrock off and let's just stick it on to the cup. Shouldn't be too hard, I think. Okay, there we go. There's our shamrock, and it's not moving yet. Don't worry, we'll get there. But let's put on some eyes. And that's the thing about toys, you want to make it interesting. I just had my son Bennett. He just turned 1 not too long ago, and one thing I noticed is that he likes cute things, and that's probably why you have all these stuffed animals that are cute, and anything that moves, especially stuff like googly eyes, he likes it even more. Okay, so we're gonna make something that my son will like, and probably a lot of kids will like. Okay, so let's put on this other googly eye. These are peel and stick here. We just peel that thing off and then we stick it on. All right, cool. All right, so that's the body of our robot. So every robot needs a body. If you want to know the technical terms, the mechanics of a robot. So the mechanics today, we have a body, which is a medicine cup. We have decoration here, the sticker, and then some eyes. Okay, so now let's get this thing to move. Now, in order to move, we need electricity. So let's talk a little bit about electricity here. I'm going to go to my whiteboard. So you may or may not have heard the term circuits. A circuit is basically a path for electricity, okay? So what we need to do is we need electricity to go through something to make our little shamrock dance. Now, what do we want electricity to go through? Looking at that top right corner here, I'm gonna take this out. This here looks like a little hockey puck, a little baby hockey puck. This is actually a motor. It's a vibration motor, and when you turn it on, it shakes. When your cell phone vibrates, it has a motor like this, that when you give it power, it shakes. Another thing is like game console controllers, like Xbox controllers, when they vibrate, it has some type of motor like this. Okay, now this is called a DC motor. We won't get into like why is it DC and all that today, but just so you know, it's a DC vibration motor. Okay, so that's what we want to move. So let's go ahead and draw the circuit or the path of electricity to make this thing move. All right, so here we go. I'm going to draw this box here, and there's a plus and a minus on it. And what is that? That is a battery. Okay, and let's find our battery. Looking at the top right, we have a battery here. Okay, it's a Coincell battery. Let's go ahead and take it out. These batteries you'll find in watches, probably the most common thing I think of. And the plus side, you'll see a plus on the top of it, and the minus is just the other side, okay, on the bottom side. So plus and minus. Cool. All right. So battery is where the electricity is. Now, how do we get the electricity out? We need to create a complete circuit, which I'm going to draw right now. All right. So we have the battery here in my diagram, and then we're going to draw the motor. I'm going to draw the motor. The motor also has a plus and a minus, okay? Now, do you see there's a plus and a minus on the motor as well? We're going to say that the red wire on the motor here is the plus and the blue wire is minus, okay? All right, so how do you make electricity come out? You create a complete circuit by connecting plus to plus and minus to minus. I'm going to use red for plus, and I'm going to use black for minus, okay? So once we do that, this is called a closed circuit. Whenever we have a closed loop, you see the red wire and the black wire create a closed loop between the battery and the motor. So let's go ahead and create our closed circuit, and we do that by saying plus to plus there, and then minus to minus. Now, one thing to note, you see there's the metal part coming out of the red wire. That's what we need to connect to the battery. And then the same thing for the blue part. If you do that, it should shake. All right, you might be able to see in the video, it's like, you know, blurry. It's because it's actually vibrating. It's actually moving. Cool. So what we're going to do now is let's connect this onto the cup. Okay, so in order to do that, what we need to do is we need to first look at our motor here, and we notice that there's this piece of paper. We can actually peel this off, okay? And this can then stick. You'll notice that this is sticky. They can stick to the top of your cup. So let's go ahead and stick this on. I like to put it kind of near his head like that, okay? And we're good. And then next we have to somehow get this battery also connected. So what we want to do is take a sticky foam. All right, there's 2 of these actually. All right, we'll just take one for now. And what we'll do is stick it down first onto the cup. Make sure you don't cover any of the wires, okay? Just so maybe push the wires up. And then both sides are sticky, so we'll make it sticky by taking that off. And then we want to make that red wire connection that you see on my top right, that whiteboard there, the plus of the battery to the plus of the motor, okay? So this is going to go here. So what we do is just put the red wire on there onto the sticky. And you see that it's important that the exposed wire on that red wire is also on the sticky. And then what we can do is take the plus of our battery and just stick it on there, and that's going to make a connection. Now, what we're also going to do is take this red wire here. You'll see one side's got a spike, okay, and one side's frayed. We're also going to take this and put this on the sticky like that. Okay, the reason why we're going to do this, you'll see later, we want to be able to access the plus of the battery. Okay, and this will make sense why we're doing it later, but I'm going to giving you trying to make your life a little bit easier by giving you a little head start. So we're going to connect this wire as well, like so. Then we take the plus of the battery, which is here. We flip it around or flip it over and then stick it on. There we go. Okay. All right. And then now, just to make sure that the plus connection is good, what we can do is take the blue wire, the exposed lead, and put it connected to the minus, which is the top of the battery, and it should move. It is definitely working. So now that we've got a basic thing going on here, we have the motor and the battery connected. We know if it turns on, it shakes, so that's cool. It's a dancing shamrock, but let's add something called a switch. The switch allows us, in our toy here, to be able to turn off and on, okay? Now the special switch that we're going to use is actually called a transistor. So what's a transistor? Check it out. Inside your bag of parts, you're going to see something like this. All right, I'm going to draw the symbol here for our transistor. Looks like this. Okay, and there are 3 legs, and the 3 legs are gate. They're named gate, G for gate. Then we also have our drain, D for drain, and we have our source, S for source. So today what I'm going to do is do something called abstraction. All right. Abstraction is very important in engineering because it's the ability to communicate as little as possible, but to still get the point across so that we can do our job. All right. If you have more questions about the transistor or anything I talk about, there's going to be links to the video. You can feel free to reach out. Hey, I want to learn more about a little bit more about that. Okay. So I just want to let you know what I'm doing. So if it seems a little bit fast, or you're like, hey, I have questions. That's what I'm doing. We don't have a full hour to go over all the components. I just want to give you like a little sneak peek, a little inspiration, so you see kind of know enough so that you can use the component. So this is a transistor. There's a gate, a drain, and a source. So the way it works is like this, okay? I'm going to draw an arrow here. Electricity likes to flow between the drain and the source, okay? It goes through from the drain to the source. So that's how the electricity flows. Now the gate, what does that do? The gate controls whether or not electricity can flow between the drain and source. So if the gate's open, electricity flows. If the gate is not open, electricity does not flow. Okay, so the gate controls everything, and the current or the electricity flows between drain and source. Okay, so now knowing that we have this component that we've learned about, how do we connect it so that we're able to turn the motor on and off? Well, let me show you. So let's modify our circuit right here. Okay, what if we did something like this? If I erase that line, okay, and I'm going to use different colors here. What if I connected the minus of the motor to the drain, okay, and then we connected then the source to the minus of the battery? So what's going to happen here now? So remember what I said, the gate controls the flow between drain and source. So we have to give a little thought experiment now, right? So if the gate is open, meaning that electricity can flow between drain and source, what happens is electricity would start here from the battery, and it could go through the drain and through the source all the way back to the minus of the battery. Electricity would flow, the motor would be on. Now if the gate is closed, what's going to happen? If the gate's closed, electricity will try to go from here, hit the drain, but look, because the gate's closed, it doesn't allow electricity to flow between the drain and source. It would stop there, and because electricity can't get all the way back around, it will not turn on the motor. Electricity actually won't even come out, okay? Because electricity needs a full loop in order for the circuit to work. All right, so that's how we connect it, and then we should be able to use our transistor to turn on and off our motor. So let's go ahead and make those connections. All right, so you can still see our little circuit diagram on the top right. Now, how do we make these connections? Like, how am I going to connect this into all this stuff? It's not very easy without another tool. So if we look at our tools, I want to point out this guy. This is a breadboard, okay? Now, what's a breadboard? Remember the abstraction thing. Just real quick, a breadboard helps us connect wires together, okay? Helps us connect wires together. Now, the first thing about the breadboard, I want you to go ahead and grab it. When we're talking about it, I want to make sure that you turn it horizontal. This is horizontal. This is vertical, okay? So turn it horizontal, because otherwise what I'm telling you is going to be totally confusing, okay? We're going to get mixed up. So make sure you have it horizontal anytime we're working with the breadboard. Okay, so have it horizontal. That's step one. Number two, as you look at it while it's horizontal, I want you to notice there are a bunch of holes here on the breadboard. And this is the special rule about the holes on the breadboard, all right? They're kind of like, imagine a lawn and there's like gopher holes, all right? Imagine there's a bunch of tunnels underground, right? There's gopher holes. Some holes are connected, like you can go in from one side and the other, and some holes are not connected. So there's a bunch of tunnels down there, all right? Now, how do the tunnels connect? This is how it works. If a hole is on the same row, those two holes are connected. If a hole is not on the same row as another hole, those two holes are not connected. All right. Okay, think about that a second, and I'll do this. I'll put this black wire right here, and I'll put this black wire, or sorry, this green wire down here. As you see, these two wires are in holes that are in different rows, so they are not connected. But if I took this green wire and stuck it up here, these two pins, they're in the same hole, same row, so they are connected. And that's it. Okay, that's how breadboards work. All right, so now that we know that, let's use this breadboard to make our connections. So I'm going to take these out for now. Okay, I'm going to take our transistor here. I'm going to put it into the breadboard. Now, when we do this, I want you to follow exactly like I'm doing. All right. So you see, if you look from top down, it's a semicircle. There's a flat side. Okay. I want to make sure the flat side is pointing to your left. Okay, just like me on the camera, and I want you to put it down here. Put the three legs like that, so the three legs are all on their own rows, right? All right, cool. That's good. Okay, now we should be able to start making our connections. So looking at the top right again, you see the transistor has a G, D, and S. So the way that these are labeled, and I apologize in advance, it's a little bit confusing. It's just the way it is. All right, that top row right there, that top leg, that's the source. The middle leg, I guess it would be row 4 in my camera view, is the gate. The middle is the gate, and then the bottom leg is the drain. Okay, so it's kind of like flipped from what I have in the diagram. All right, but I know you guys can handle that. So the first thing I want to do is, why don't we connect the drain to the minus of the motor? So I'm going to take my little highlighter, okay, and I want to connect the minus of the motor to the drain of the transistor. All right, and I highlighted it in green so you can see that connection, the minus of the motor to the drain of the transistor. All right, so what we're going to do then is take this green wire, okay, and try to color code this thing as best as possible so we don't get confused. The green wire, we want to take the frayed part and connect it to the minus of the motor, which is the blue wire right here. Okay. Now, in order to do this, we're going to need a little bit of finesse, a little bit of patience. We got this. To make this connection, take the two metal parts and then you make like a little cross. Okay. You see it's a little cross, and then we're going to twist. Cross, and then we twist. So it takes a little bit of finesse, a little bit of patience. You can do it. You can do it. Maybe some of you guys are starting to want to complain, but no, we got this. We're toy builders. We're engineers. It's all good. Okay? So we are connected. Now, where does this go? This needs to connect to the drain of the transistor. So the drain of the transistor, remember, turn your breadboard horizontal. The drain is actually down here. Boom. There we go. Now we've done that green connection that's highlighted. All right. The next thing I want you to do is connect the source of the transistor. Needs to connect to the minus of the battery. Okay, the minus of the battery. The minus of the battery is actually up here, right? That surface. So let's get this black wire and let's put the frayed side on there. And then the next thing that we're going to do, you're going to find a sticker, this sticker here, okay, little Barnabas sticker, and we're going to stick it on. Now the little tip here, you want to just tape the frayed part to the battery like that. The reason you want to do that is if you also tape the black side, the black protection covering onto the battery, it kind of like makes it bump up a little bit more, and then you might have a not as ideal connection. Okay, just a little tip. All right, so now we know that this black wire is connected to the minus of the battery, and that goes to the source. The source is going to be the top row of the transistor. There we go. Very nice. So we've done that. Now it's not moving. So what is the deal here? Okay. The deal here is that in order to turn on the gate, we need to connect the gate to the plus of the battery. And then just so you know, in order to turn off the gate, you need to connect the gate to the minus of the battery. So let's turn on the gate. So remember, that's why now this red wire is connected where? It's connected to the plus of the battery. So I can connect this to the gate. Our switch should turn on. Let's try. And hopefully this should work. The gate, remember, is the middle row. It works. Amazing. And then take it off, and then it should stop. All right, so I still have a few components here. So what's the deal? We're gonna bias our circuit so that it's naturally off. Now bias, what does that mean? Bias just means that when it turns on and when nothing else is happening, we want our motor to be off. Now why is that the case? It just makes sense, right? Imagine you're driving a car or something. When you turn on the car, you don't want it to be moving right away, right? You want it to be stopped. And then when you press the gas, it turns on. So same thing here. Now, in order to do that, we're going to bias the transistor to be off. The way we do that, we take a resistor, which is this squiggly line symbol, connect one side to the gate, and then the other side to the minus of the battery. Remember the minus, if I connect the minus to the battery, it turns off the gate. And I'm going to put 10K here. All right, 10K stands for 10,000. So it's 10,000 ohms is the value of my resistor. Now, why do we use 10,000, not like 1,000? That's a conversation for another day. If you're curious to learn more about a resistor and why we're using that to bias it to turn off, feel free to reach out. Okay, so let's get our resistor. And this will be our biasing resistor to make sure that the robot is off when we first turn things on. So one side connects to the gate and the other side connects to the source, which is also connected, the source of the transistor, which is also connected to the minus of the battery. So one side to the gate, which is the middle row, and then the source. Other side, which is the top row there. There we go. Now, what else should we do? Well, we have one last thing. All right, so we've biased our circuit to be off, and it's not working right now, so that's not super exciting, right? But we bias it for a reason, because we're also going to add this super cool thing to add light control. So how do we do that? All right, so I'm just going to leave my camera view right here. If you look at the top right of the whiteboard up there, I'm going to create another resistor connection. Okay, and I'm going to draw a couple arrows right here. All right, so we have another resistor up there with a couple arrows going in. The arrows represent light. So what's going to happen is that you're going to have another resistor that changes, it actually behaves differently depending on the amount of light it receives. And that's this thing. Okay, so this is a photoresistor. So this is a regular resistor down here. This is a photoresistor. So this resistor right here is always going to be 10,000. Okay, it's always going to be 10,000 ohms, which is the unit for a resistor. Now this is a photoresistor. Depending on the amount of light, the resistance, the value actually changes. Sometimes it's like 50, sometimes it's like 5 million. Okay, so now why is that cool? Here's the thing, as the resistance changes on this, it will control whether or not the gate turns on or off. And there's some math involved there, again, something we can explore more and talk about, but just so you kind of know from a top bird's eye view, that's what's going on. If the resistance changes here, that can control whether or not the gate turns on and off. So let's make a connection, and then we're going to see if this thing actually works. Here we go. So one side of the photoresistor goes to the gate. It's the same row, this middle row here. Okay, and we want to. The other side of the resistor or photoresistor goes to the plus of the battery. Remember, this is the plus of the battery, so we're going to make another row, a new row, this top row up here, and connect it together using that top row. There we go. Okay. See, if I cover it, it totally turns off, right? If I uncover it, it turns on. Cover it, turns off. Now, if your room is a little bit dimmer, because mine's a little bit bright right now, your robot might not turn on. So what you can do is shine a flashlight on that, and it will turn it off. Now, what you can do now is there's another sticky foam. If we want to kind of complete our project here, you could put one side over here and the other side here. All right, and you see here my black wire came off here, so I might need to fix that. And that's the thing, if it comes apart, I just want you to have the confidence to be able to fix it. Okay, there we go. And that's part of this learning process, right? It's not that you made the most robust toy right here. The value of today is actually we've kind of learned some things, and we've built this thing from scratch, just from a bunch of parts. So I'm going to try to turn off my my top light here. And see, once we do that, it's totally off. And let's see if I use my phone right here to give it some light. Let's see if I can control it with my cell phone. Pretty cool. Okay, I don't know about you. I've done robotics for 10 years. I've seen advanced robots in different countries. I think this is pretty cool because we made this all just from all these little components. All right, that's all I have for you today. I hope you learned a little bit something. Again, if some of it went a little bit fast, I just want you to know that this today was more about inspiration than anything. You know, my goal was for you to get a little bit excited about, you know, you hear about STEM. You know, what is that? Maybe some of you guys think STEM is not for me, and maybe it's not, and that's totally fine. But I wanted to give you another side of STEM that sometimes we don't think about. You know, toy building is a part of STEM, and it's kind of fun at times. Okay, so enjoy. If you have any questions, again, feel free to reach out. I am here to encourage and to teach. So thanks for your time. Take care. Have fun. Bye.